Welcome to Skills and Academic Tuition Center. It is your favorite teacher, Kaumaji Mwasa. In this video, we look at the rate of reaction. The rate of reaction is the change in concentration of a reactant or a product with time. So basically, in a reaction, there must be a reactant and a product. So any decrease in concentration of a reactant is the rate of reaction. So let's look at this graph here. So basically the graph shows the change in concentration of the reactants and as well as the products. So as you can see, there is an increase in products as well as a decrease in the reactant. So therefore, the rate of reaction is equal to change in concentration divided by change in time. Let's try to look at some of the factors that affect the rate of reaction. So the first one is concentration. So the question is, how does concentration affect the rate of reaction? So any increase in concentration of one or more reactants increases the rate of reaction. Any increase in concentration of one or more reactants increases the rate of reaction. So what does it mean by this statement? So this is basically due to the fact that there are more particles in a given volume, hence the frequency of effective collision increases. So when you look at this diagram, it shows two different boxes, one with less effective collision, meaning there is low concentration of particles, the other one with more effective collision, because there is an increase in the number of particles. So therefore, any increase in concentration increases the rate of reaction. The second one is size of particles. Decreasing the size of the reactant particles will increase the rate of reaction. So in short, we are saying the smaller the size of the particles, the faster the rate of reaction. When you look at this graph here, it shows that the smaller the size of particles, the faster the rate of reaction, and the larger the size of particles, the slower the rate of reaction. The other one is pressure. How does pressure affect the rate of reaction? We can say the higher the gas pressure, the faster the rate of reaction. So in terms of pressure, we also look at volume. So meaning the smaller the volume, the higher the rate of reaction. Now, when you look at this diagram, there are two cylinders, one with less pressure, the other one with more pressure. So the bigger the volume, the lesser the pressure. Then the smaller the volume, the higher the pressure. In short, pressure increases as you reduce the volume. Another one that we can look at is temperature. So in terms of temperature, increase in temperature of a reaction will result into a higher rate of reaction. So the higher the temperature, the faster the rate of reaction. Now, what does this simply mean? So it means that at higher temperature, the particles will have a greater kinetic energy, resulting into the speed movement and more frequent effective collisions. So the higher the temperature, the more the kinetic energy possessed by the particles, and that will result into frequent collisions. Now we look at the diagram here. So when the kinetic energy is increased, you find that there will be more particles with sufficient energy, and the portion of collision by the particles will increase as compared to the particles that possesses low kinetic energy. Catalyst as that affects the rate of reaction. So by definition, a catalyst is a substance that speeds up the rate of reaction. A catalyst is a substance that speeds up the rate of reaction. As it speeds up the rate of reaction, it provides an alternative route for the reaction with the lower kinetic energy. So here now, A catalyst does not lower the activation energy. What it provides is an alternative route for the reaction with a lower activation energy. So when you look at the diagram, there is a high activation energy without the catalyst. So when a catalyst is introduced, it provides a route with a lower activation energy, and this will enable the reaction to occur at the faster rate. Thank you for watching. Value for education, our pride.